So we're going to be starting with quantum physics. In today's segments, we'll be looking at a short motivation as to why we study quantum physics or why the study of quantum physics emerged in the first place, and then we'll be looking at one small derivation. So we start first with the historical perspective about how this whole idea of quantum came into place. So what is quantum? To start with, quantum basically means a small unit. So quantum means small discrete units of any quantity. For example, small packets. Now discrete is the key word here. Why? Most quantities in physics and mathematics generally, we assume them to be continuous quantities. Continuous meaning they can take any value within the specified range. For example, if you consider height or weight, let's say it's around 150 centimeters, meaning it can be anything, 150, 150.1, 0.2, 0.25, anything. So you cannot specifically state these are the only values this quantity will take. But for a discrete quantity, that's not the case. You can specifically state and list the values it will take. It can take an infinite number of values, but you will still be able to list them. For example, if I take real numbers, they are continuous. It's a continuous line. You cannot specify discrete points on that line. But if I take natural numbers, they are discrete. Natural numbers are also infinite, but you can specify points 1, 2, 3 and so on. So there is, every number has a before number and an after number. So that's what we mean by discrete and continuous. And quantum refers to the smallest unit of a discrete quantity. So why is this quantum physics a big thing? Because for a long time physicists assumed that any physical quantity is continuous in nature, meaning any quantity which we deal with in physics, mass, acceleration, energy, potential, voltage, anything, they thought it can take any value along the real line. Non-negative maybe, for example your mass and volume cannot be negative, but apart from that they thought it can take any value along the real line. And for some quantities that is true. For example, your mass and volume are continuous quantities, but they extended this assumption to all physical quantities, and at that time they started running into some errors. They performed some experiments assuming energy to be a continuous quantity, and they did not get the results they expected. So that's when they realized probably this assumption is wrong. Maybe energy is discrete, so it can only take certain specific values. So energy is quantized, or there are small packets or small units of energy called quanta. So that is how the idea of quantum mechanics as opposed to classical physics came about. So that's the basic idea of quantum.